Hey everybody, this is Larry. This is me doing week 2 of the June weekly challenge, whatever it's called. Hit the like button, the subscribe button, join me on Discord. Let me know what you think about this one. Apparently I already solved it, so the probably is already video out. But yeah, just realized that I didn't do it yet. So let's take a look. We have 255 verified pre-order sequence in binary search tree. Okay, given a unique integer pre-order, return true if it's the correct pre-order traversal sequence of a binary search tree. Okay. Oh, it's a binary search tree. Okay. So what is a pre-order, right? Pre-order means that we visit all the children first recursively. So in this case, oh, sorry, the other way around. That's post-order. No, pre-order is parent left, right? So, and it's a binary search tree. So then now, yeah, it's going to go from the root. So then it's just one root at a time. Yeah, and then I mean, you can implement it probably in a number of ways. I like to do it with an implicit stack. So let's get to it, right? So then maybe you have an n is equal to and then maybe a current is equal to current marker, so we just current 0, and then here we just like a parse or consume, maybe you want to call it that, maybe consume, right? And then now we have pre-order of current, right? So this is the current node value. And then now what does that mean? That means that you know, we consume, so left is equal to, so yeah, consume is going to be we basically want to do in a pre-order, this is going to be recursively consume left and then consume right. I'm just trying to think about how I would want to what to return here, right? Maybe I could return the min and the max values so that it could be used. So then maybe that'll be fine, right? Like I'm just trying to figure out what to do. And then here maybe left min, left max is equal to this, right min, right max. Of course, it might not, you know, this may return no's, right? But, and that's fine, right? So here maybe we can write something like, we have to do it anyway. Also, right? But yeah, which is that if current is greater than or equal to n, then we just return, let's say, yeah, let's say none. Maybe a better flag or something like that, but I think that should be fine, right? So then now this is just that if the current node has to be between left max and then right min, right? That's basically the idea, but there are some none cases. And because of none cases, maybe we can just set this to negative infinity to make it a little bit easier, and infinity here to make it slightly easier for us to handle for those cases. I don't know if this is quite right yet, but that's basically the idea. If this is good, then well, we're just true, right? But if this is not good, then now we have to kind of change. Well, now it's false, right? So maybe good is equal to false, and that's it. And then we can set good is equal to true. And then now maybe, yeah, we can do a consume. We can return good. Hopefully this is relatively good. Non-iterable, non-type. Oh, I forgot to return. And then now, given this node, we have to return, let's see, left min, it's going to be the min, and then right max, it's going to be the max of this subtree, right? Okay, so here it's good, but you know, with two results, it's always tough to figure out if this is good or not. It's still, I wish there's like a visualization, but I guess maybe since it's not a tree, then okay. So 5, you have 2, and then I mean, this is actually the way that I did it is kind of wrong, because I don't know that. How did I do it? And maybe today I'm just not thinking right. But okay, so this is recursive and looks good, but we have to make sure that because we have to figure out, like, okay, let's say we have this one, right? We have to figure out that because the way that I did is basically I created a linked list, which is no bueno. But what we really needed to do is some sort of a forcing function, I suppose, right? Meaning that if the next, because you can also have like let's say you have this subtree of 5, 2, and 3, then that's still good. It's gonna be 5, 2, 3, even though 3 is on the right thing, right? So okay, let me rewrite this. Maybe I'm like doing it really weird. Maybe I'm thinking of something else. That's my apologies, friends. But you know, here this channel is meant for mistakes and exploration. Otherwise, you just watch another video. Okay. Though honestly, I also just don't find this that interesting. So I don't know. But yeah, okay. I mean, I think the consume part is maybe, but okay, so you can't consume because you don't know where it is until you don't know where you need to know what the Lex token is, right? So what does that mean? That means that okay, I don't think this is a great way of doing it. Actually, I think what I want is actually do it using a stack or something. Yeah. So basically, you have a stack, right? And that will represent the root. Let's see, how do I want to write it? Then now for x in pre-order, then there are only a couple of ways. So then stack.append x will put it on the top of the stack. So if length of stack is greater than 0 or equal to 0, then we just continue. Otherwise, then now we have to figure out if this is on the right side or the left side, right? And obviously, if x is greater than the unique integers, okay. So if that, then this is going to be on the right side. Otherwise, it's going to be on the left side, right? So maybe this is a little bit more straightforward. Left side, right, of the next number, right? Yeah. Otherwise, but this isn't quite right either, right? Because, well, not sufficient. Because, for example, if you have something like this, and then you have 5, 2, 6, right? Well, the 6 is going to be, the top of the stack is going to be a 2, but you wanted to, yeah, like, I think I'm just, okay, I think I'm trying too hard to be a little bit, I think the first thing to do with these problems should have been try to figure out with invariance, right? Which means that, yeah, it's almost like a divide and conquer thing, right? Because now this is pre-order, everything to the, we go to the first number that is greater than, say, the root, and then that everything here is to the left, right? So, okay, so let's look at that, right? For now, we'll do it like n square-ish, 10 to the 4th. It's kind of a little bit slow, actually. But yeah, here maybe we, let's just say we want to calculate, right, from 0 to, left, right of the pre-order array. Let's say inclusive, right? So that means that, okay, then current node is equal to pre-order of left, right? That means that now we're trying to find the first number that is bigger than node, right? Larger than node, because that means that that's on the right subtree. So then now, or alternatively, I mean, yeah. I mean, we'll write it in a naive way for now, right? From left plus 1 to right, because it's inclusive, so we have to do, right? So let's say mid, if pre-order of mid is greater than node, then now we want to, so then now the right side is going to be calculate mid and right, because it's inclusive, and then the left side is going to be calculate left to mid minus 1, right, or left plus 1 mid minus 1, because left is the root, right? And so then now these has to return good too, right? So that means that if this is the case, then if this and this, then we return, I want to say we return true. But we still have to check that order, because even if the subtrees are true, we have to do the min max thing, right? That we kind of talked about, did earlier, right? So I think this is the same idea as before, actually. So then now we have left min, left max is equal to this, and then right min, right max is equal to this, right? And then now, if, so then also else continue, right? And then now we want to return left min, right max, but also the same thing that we already did actually. If not left max is right min, then we return or then good is equal to false. And I don't know, we just return some junk value. It doesn't really matter, right? Well, I guess we still return anyway. It doesn't really matter anymore because now it is no good, right? So now from 0 n minus 1, and then we return good is the idea. Otherwise, then here we return, I want to say, if none of them, then now that means that everything is on the left. So then now we want to say left min, left max is equal to calculate calculate left plus 1, right, and then we just return left min, and then node is the right max. But there's also like a base case of if left is equal to right, then return node. I think that's fine too. I don't know if this is good, honestly, but syntax error. Oh, whoops. But yeah, oh yeah, I have to also write if left is greater equal to n, then we just return infinity, negative infinity for default value. That means that we ran out of things to consume. Looks good for these two. Honestly, am I confident about this? Not really, but I'm too lazy, too tired to YOLO submit. And hopefully this is good. Oh no, well, this is going to time out. I forgot. I talked about optimization and I totally just forgot about it. Well, mistakes were made. Oh, it's wrong. That's even worse. And only 20. Why does it take so long for 20 seconds? Anyway, 1 and 2 is wrong. Why is 1 and 2 wrong? Oh, wait. Left max is negative. That should be right? If this is plus. Okay, so I guess left left is greater than right, I think. Because left is greater than right, then this should have not a thing. Why would this maybe this left min is a little bit weird with this sentinel. I don't this sentinel values are a little bit awkward for sure. Because I did it for these sentinel values are chosen for this, but and maybe that is just wrong, to be honest. Why would this be left? Oh, okay, let's actually see, right? If left is greater than right. Okay, you have 1 and then 0, so of course it's false. Wait, why is this 1 and 0? Oh, wait. Well, then just return. It's a little bit weird, but because basically this is saying that 1. Okay, we just have to walk through the code. I think even with the printing, it goes 0, 1, 0, 1, and then now it goes mid. It finds the first number. So then the left side is going to be 1, 0, which makes sense because it doesn't have anything. So then just infinity, negative infinity. So then now it is going to be. I think this is min of this and node, and maybe max of this end node is a little bit more precise. Okay. I was just trying to be lazy to not do that, but maybe I should have done it anyway. I don't know. Clearly, oops. But we still are running into this thing where this is too slow, right? Because of this for loop. So that means that we have to find given a number, we have to find the next number that is bigger. And there are two ways to think about it. One is that the way that we're doing it is recursive, so that's no bueno with respect to this. Honestly, maybe that's fine actually, because this isn't O of n. It just finds the biggest number, but then we recurse on it anyway. No, because then now you have n. I don't know. YOLO submit. I think this may be too slow though, but. No, because we only do it once per. I mean, it's not fast, but it's definitely too slow. Because that's you only do it once per thing and not an n square, because this isn't. But probably we could have done a little bit faster. But you could pre-process this with a mono queue or mono stack to get the next number that is bigger. And once you do that, you can do this in like O of 1, and it just becomes n log n type thing, and then it becomes linear, right? So okay, let's optimize. Let's do that then, right? So then now we will optimize using a mono stack. I think, is it mono stack? I don't know, right? So then yeah. So then now we have pre-order of the reverse, because I don't like it reverse, and then now we have a stack. And then if length of stack is 0 to 0, then we just stack dot append x. I probably could change the default case. Okay, then otherwise, while length of stack is greater than 0, and the top of the stack is if the top of the stack is I have to always think about this. If the top of the stack is greater than x, then we pop it off now because we want the next bigger, right? So okay, yeah, oops. Then we stack dot pop. Otherwise, stack dot append x. And actually, I messed up here in that I need to keep track of the index. Okay, fine. So then maybe we do for I in range of n minus 1, right? So then now x is equal to pre-order of I. And then now we can just do ix, add the index there. That'll be the first element, ix, right? And then but we also want to pre-calculate the answer, which is the next greater is equal to I don't know, n, I suppose, times n. And then now we can update next greater sub I is equal to the top of the stack. I should use the sentinel. Okay, right? And then now, instead of this loop, we can say mid is equal to next greater sub left. Yep, maybe. And then now we can do it, right? I think. Let's go quick submit. Yep, only a little bit faster though. Honestly, I thought this would be much faster. I mean, actually, it is much faster. It's just that percentile-wise, I suppose. Percentile-wise, I went from, I don't know where I was, but I guess I was just like really far off. Can I do a little bit better? Apparently, this should be linear or n log n at worst. No, I mean, should be linear. Divide and conquer would be n log n, so does it make sense for this to be linear? Well, it's lit. Yeah, it's n log n in the worst case, I think. But how did I do it last time? Seems like I did it pretty much same thing. What is going on? What am I doing here? Why is this so? And that is only slightly slower, but what am I doing here? Oh, sealed infinity. Oh, we just keep on consuming, and then either we consume to the left and then we consume to the right, and we just keep going. Oh wow. Alright, old past Larry is cleverer than I am, though apparently there are better solutions. So I don't know. But that's all I have for today. Let me know what you think. This is linear time, linear space, so I lied again. This is n log n. I mean, this is because this is in the middle, then we just do all these recursive log n steps. And that's it. That is all I have for this one. Let me know what you think. Thanks for watching. And yeah, stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye.